This is section 7.1 on the Pythagorean theorem. In this video, we're going to look at the rules for simplifying radical expressions. So in this section, you're going to be faced with this issue a lot. We're looking for the square root of 8. This is a radical. This number is called a radicand. Square root of 8. What does that equal? Well, if you remember in previous videos, this is almost the square root of 9. The square root of 9 is 3. So the square root of 8 should be a little bit less than 3. And if you want to, you can type it directly into your calculator. Square root of 8 equals, I'm going to round to 2 decimal places. 2.828 are the first 3 numbers. So I'm going to round my 8.2 to an 8.3 because the third digit is 5 or bigger. This is how you would simplify this to the nearest hundredth. Now, if you want to simplify using simplest radical form, then there are rules that you have to follow. And I'll show you what each of those rules are. But first, what I'm going to do is I'm going to simplify this radically because I know you've seen this before. You're going to use your perfect square list, and you're going to split the square root of 8 into 2 radical expressions, where you're going to put a number here and a number here where they both together multiply to give you 8. Now, the trick to it is, using your perfect square list, you need to find a number from your perfect square list that goes into 8. So if I would take a step back here for a second, remember these are your perfect squares. The number 8 lives here, it's not on the list, but doesn't 4 go into 8? So that's one of the numbers you want to use. You want to use 4, and then the other number you use is the number that multiplies with 4 to give you 8. Now, once you've done that, you're going to get the answer really quickly because the square root of 4 is just the number 2. There's no radical. The square root of 4 is 2. The square root of 2 is not going to simplify because if you look at your perfect square list, there's no perfect squares that go into 2 besides 1. But 1 goes into everything. So we don't use 1 when we go to simplify radicals because it goes into every single number. So it's not going to simplify it at all. So 2.83 is the same thing as this, but this is your simplest radical form. This is actually a rounded version of the exact answer. This is the exact answer. So this is a better representation of the square root of 8 than this is, because this is rounded. Okay, so when we're looking for simplest radical form, don't give decimals. Simplify radically, and we're going to do a lot of practice with that. Okay, but before we do that, we need to know the rules. Okay, so here's rule number 1. There are no perfect squares other than 1 in the radicand. So here's your radicand. There was a perfect square that went into that radicand. That's why I had to split that up. This was not simplest radical form, but this is. The radicand cannot be a fraction. So for example, I'm just making this up right now. Not doing a great job of it. (16/9) is your radicand. You're not allowed to leave it like that. You have to simplify it. And we're going to talk about some rules that we're going to use to simplify this also, some properties. What you can do is, kind of like what I did here, if you want to break the square root of 8 up, you can do it by finding 2 numbers that multiply together to give you 8. Well, it's kind of like the same concept here. If you're taking the square root of a fraction, you can also take the square root of the numerator and divide that by the square root of the denominator. So instead of taking the square root of the whole thing, we can take the square root of the numerator and the denominator. Now, that's going to cause an issue also, because rule number 3 says the denominator cannot contain a radical expression, and our denominator has a radical. And there's ways around that. This is an easy type of problem to simplify, because we know the square root of 16 is 4. No radical. 4 times 4 is 16. Square root of 9 is 3. That's your simplified answer. Notice how there's no radical at all. So of course it's in simplest radical form. Okay, so to review the rules, you can't have a perfect square that lives inside of your radicand. If you do, you got to fix it. You can't have a radicand that is a fraction. If you do, you have to fix it. And you can't have a denominator that has a radical in it. If you do, you have to fix it. And there's a lot of little tricks that we're going to pick up as we go, but these are the 3 rules that we're going to follow. Okay, so those properties that I alluded to and kind of used in that last slide are written out here. There's a product property. Product means multiply. So if you multiply 2 radicals together, square root of 2 times the square root of 3, that gives you the square root of 6. Now, there's also what's called a quotient property. And the quotient property deals with division. So it would be the same type of thing. So how about I do this? Oh, I didn't want to do that. How about I do this? If you have a radical of a fraction, you can change it to the radical of the numerator divided by the radical of the denominator. Or vice versa. If you have this, you can switch it to that. If you have this, you can switch it to that. Or if you have this, you can switch it to that. That's your product and your quotient properties.